Hey guys, Dr. Brown here with Kubo Math coming to you from Tarlac City, Philippines. I'll apologize for my voice. I'm a little under the weather. I have a cold, but I wanted to push ahead with the videos and try to stay ahead of the schools. So just bear with me on my voice. So let's jump into it. Tonight we're talking about inverses, whether that's an additive inverse or a multiplication inverse. Now, a multiplication inverse is if you add two numbers together, you get 0. One is the inverse or opposite of the other one. So a negative m plus m equals 0, which is the same as m plus a negative m. So if we have a list of numbers here, what would the inverse, the additive inverse of 6 be? So it's a number that when we add them together, we get 0. Well, 6 minus 6 equals 0, which is the same as 6 plus a negative 6. Recall our number line. Here we are on our number line. Here's 6. 6 plus a negative 6. If we always change it to plus, then the sign of this number tells us which direction to go. 6 plus a negative 6, this is a 0, negative side, positive side. We're headed toward the negative side. 15, what would be the additive inverse of 15? 15 minus 15 equals 0, which is the same as saying 15 plus a negative 15. Again, we're at 15, we're going toward the negative side. 27 minus 27 equals 0, which is the same as 27 plus a negative 27. Okay, but what about a negative 5? What do we add to a negative 5? Now we're over here. Let's say that's negative 5. We need to end up at 0, so plus a positive 5. Negative 5 plus a positive 5 would give us 0. So the additive inverse of a negative 5 is 5. But what about the negative inverse of x? Let me clean this up just a little. What's the negative inverse of x? Recall, any two numbers we add together, when it gives us 0, that's the additive inverse. X minus x equals 0. Or x plus a negative x, which is the same thing, equals 0. So in this equation, 45 plus x equals 0. If we were to solve for x, what would we say? Well, here we are at 45 on our number line, plus a negative 45 would allow me to come back to 0. Now we could algebraically solve for this. So if we said, let me move x minus 5 for just a moment. We could say I'm going to take 45 minus 45. Well, keeping with our numbers signals. 45 plus a negative 45 plus x. Now we added a negative 45 to both sides. So which gives me plus a negative 45, gives me minus 45. So 45 plus a negative 45, those cancel. I'm left only with x. X equals a negative 45. We'll work many equations as time goes along. What about this x minus 5? Well, this one would become simple. I could add 5 to both sides. X minus 5 plus a positive 5 equals 0 plus 5. Well, a negative 5 plus 5, those cancel. which leaves me only x. So x equals 5. So again, you can solve that algebraically, but this would be simple just to look at. So those are additive inverses. But what about multiplication inverses? It's really the reciprocal. In this example, m times 1 over m. 1 over m is the reciprocal of m. Recall, m can be written as m over 1. We don't write it that way because it's the 1 underneath is understood. But if you just flip that fraction over and put the 1 at the top, the m on the bottom, how do I multiply those together? What's the rule? If I have a over b times c over d, I multiply the numerator, what's on top, the numerator, together, a times c, divided by b times d. So that's exactly what I have here. M times 1 is m. 1 times m is m. 1 divided by m is, if you say 0, I'm coming to your house. M divided by m is 1. 1, because 1 times m gives me m. So that's 1. So that would be an example of a multiplication inverse. It's just the reciprocal of that number. So what would be the multiplication inverse or reciprocal of 3? Well, that's 3 over 1. So if I flip it over, it's 1 over 3. 3 times 1 is 3. 1 times 3 is 3. 3 divided by 3 is 1. What's the inverse or reciprocal of this number? 12 over 1. Flip it over, 1 over 12. Equals 12 over 12. 12 divided by 12 equals 1. What's the reciprocal of this number? Oh, well, just flip it over. It's 3 over 1. We had that in one earlier. So 1 times 3 is 3. 3 times 1 is 3. 3 divided by 3 is 1. 1/12 would be the same. It's 12 over 1. That's its reciprocal. Multiply those together. 12 over 12 equals 1. And lastly, 1 over 8. That's just 8 over 1. I'll flip it over. And that's 8 divided by 8. And that's 1. So those are examples. Negative, I didn't put in a negative example. Let's just take -3 for example. -3. What's the reciprocal inverse of that? Or the reciprocal? Well, it's -1/3. So now I have a -3 times a -1. So a negative times a negative is a positive. So that gives me a +3. -3 times -1 is a +3. 1 times 3 is 3. 3 divided by 3 is 1. So that's the way you would work with the negative reciprocals. You want to have a number such that it's reciprocal. Once those two numbers are multiplied together equals 1. These are just some simple examples of additive inverse, multiplication inverse, but you'll need to know these as we move along, because they will come in very useful as we get into higher level calculations. Hopefully this helps. Again, sorry for the voice tonight. Study your rules. Go back and study those always, because we had a few rules that we used here tonight. We'll always use them to be able to play the math game. So keep studying them, because together let's build a better tomorrow. Look forward to talking to you again, and you have a great evening. Talk to you soon. Thank you.